So for question 4, what we're dealing with here is the t-substitutions, or the half-angle substitutions. So it's quite a big question. I think it's actually quite intimidating, given how much information we've got, the graphs we've got, the different equations. But take it step by step. It's just like any regular question. So let's have a look at part A first. So what have we got to do? Well, we're told are asked using the models and figure 2. So these are the figure 2, or this is figure 2, and these are the models. We have to determine whether or which curve corresponds to the rabbits and which curve corresponds to the foxes. Just find our answer. So the easy way to do this, if it's not clear to see at this point, we have to think about what happens when t is 0. Right? We need to use this graph here, and the easiest time to do that is when t is 0. We're going to compare which of these graphs is higher and what value comes out higher here. Because whichever is the higher value, clearly is the dotted one, which is curve 2. So let's do that. So t is equal to 0. So plugging these in now, you're going to plug them into here. So r will be equal to 48 plus 29 cos 0 minus 3 sine 0, and so on, right? So what we're going to get is that r is going to be equal to 48 plus, so if you don't know off the top of your head, cos 0 will be 1, so that's plus 29 times 1, so plus 29. Sine 0 is just 0, so that just cancels, and then it's going to be 3 plus 2.2 on the denominator. So it's going to be 3 plus 2.2. And that simplifies, or gives us a value of 14.807, blah, blah, blah. So we'll just leave it 8.807. So that's the R value. Let's work out the F, and whichever is the higher value is clearly curve 2. So F is going to be equal to, it's going to be 5 plus 40 plus 26.3 plus 26.3. That's my numerator. And then for my denominator, I'm going to have 3 plus 1.7. Again, the sign's just going to cancel. So 3 plus 1.7. And this is going to simplify to give me, it's going to give me 19.106 and so on. So what that means is that curve 2, so the higher one here, is the higher value, which is F. So that is it foxes we're working with here? Yeah, foxes. So F, so fox is curve 2, so we'll call it C2. And then the rabbit's rab is C1, curve 1. So that's part A done, so that's the first 2 marks. Let's have a look at part B here. So part B, hopefully I'm going to have enough room if I reel it off there. So part B, we're given the substitution now, t is equal to tan t over 2. And we have to prove that the equation for the population of the rabbits can be written as this, r equals, and then so on, the 2 quadratics. So for this question, you need to know the t substitutions. So they're not given, or they're not for Edexcel given in the formula book, so you either need to learn them off by heart, or you need to know how to derive them. So I'm not going to try to derive them in this video, I'm just going to write them down, but make sure you know how to do them, guys, or how to, memorize it or derive it. So doing this, so that's going to be r, so this is this equation here, so r is going to be equal to 48 plus 29. So remember now, so for t, here for the t with cos, so that's going to be 1 minus t squared, as the numerator, 1 minus t squared, 1 minus t squared divided by 1 plus t squared. So like I said, guys, these aren't in the formula book, so you do need to know 1 plus t squared minus 3 lots of 2t, that's my numerator, divided by 1 plus t squared. That's a squared, not a z, so t squared there. So that's my numerator, let's do the denominator. This is going to be 3 plus 2.2. So it's cos again, so it's the same here, 1 minus t squared. 1 minus t squared divided by 1 plus t squared. Let's do the same now here. So it's 0.5 sine t, so it's going to be plus 0.5 plus 0.5 2t divided by 1 plus t squared. So this is quite a messy question, so be very careful with what you're writing down here. I've nearly twice tripped up with signs. It can be really easy to get caught out with this. So then the substitutions put in. Now we need to cancel and simplify the expressions here. So the easiest way to do this is multiply through by the denominators in these parts here. So notice my numerator would become 48 times 1 plus t squared plus 29 1 minus t squared, because this denominator is going to cancel here if you times it by 1 plus t squared, minus 3 times 2t, because again we're timesing it by 1 plus t squared. So if I do that, what I'm going to get is this. So therefore R, so that's going to be 48 lots of 1 plus t squared, 1 plus t squared, plus 29 lots, plus 29 lots of 1 minus t squared, minus 3 lots of 2t, so minus 3 lots of 2t. This is going to be divided by 3 lots of 1 plus t squared. Again, we multiply through in the denominator as well, so where you've got 1 plus t squared, we'll do the same here. We times through the full expression by 1 plus t squared. So 1 plus t squared, 1 plus t squared, plus 2.2 lots of 1 minus t squared, because this denominator cancels here now. 2.2 lots of 1 minus t squared. And then finally, we're going to have 0.5 lots of 2t. So 0.5 times 2t. So what we're going to get now, or how we're going to approach the next step, is we need to just cancel and simplify again. And the way to do this is just to multiply and expand the brackets up here and down here, right? So this is going to be 48 times 1, and then 48 times t squared. So I'm going to get 48 plus 48 t squared, and then I'm going to get 29 plus, in fact, sorry, minus, because it's plus times a negative. So it's going to be minus 29 t squared, and I'm going to get minus 6t at the end. So what I'm going to do is I'm going to quickly write it all out. So what we're going to get here, hopefully I'm going to have enough room. I'm going to write it down here actually. So I'm going to get 48 plus 48t squared plus 48t squared plus 29 plus 29 minus 29t squared minus 6t. And this is going to be divided by 3 plus 3t squared. And then I'm going to get plus 2.2. Again, just keep expanding down here. Plus 2.2 minus 2.2 t squared. And I'm going to get a plus t at the end. 0.5 times 2 just gives me plus t. And then when we simplify this, this is where we're going to get this expression here, what we're required to get. So if you do 48t squared minus 29t squared, you get 9t squared. If you do 48 plus 29, we get 77. It's perfect. It will simplify perfectly. So what that's going to give me then is 19t squared. 19t squared minus 6t. Make sure you just do it in the same order, just to look a bit more clearer. I'll look a bit nearer. Plus 77 divided by 0.8t squared. Because again, this is 3t squared minus 2.2t squared, it's going to be 0.8, so it does work perfect. Plus t plus 5.2. And there we go. So that's part A and part B done. Let's move on to part C. So carrying on with part C, we have to find the third time in the biologist model where the number of rabbits in the population is 25,000. So it's 5 marks, and there is quite a lot going on. So let's have a look at tackling it. So first off, we need to use the model that we've just worked out, this simplified version here. It's going to make life a lot easier. Now, because this is, 25,000, well here, it tells you that the size is already in thousands anyway. So I'm just going to put R here as 25, right? This model here is equal to 25. That would be the 25,000. So what it technically is here, if I do it in black, this is equal to 25. So just see me writing out that extra line of working. And what's going to happen then is we're going to do 25 times 0.8t squared, plus t plus 5.2. We're timesing the full x denominator here by 25. So doing that, I'm going to get 20t squared. 20t squared. So 25 times 0.8 gives me 20. So 20t squared plus 25t plus 25t plus 130. And this is just equal to whatever's left as the numerator. So that's just 19t squared. 19t squared minus 6t plus 77. Plus 77. Now we need to simplify this and see what we get left with. So we're going to get left with 20 minus 19, so it's going to be t squared. Simplifying the 25t, so add 6, it's going to be plus 31t. And then 130 minus 77, so that's going to give me plus 53. And this is equal to 0 now. So now we have a quadratic. Let's solve it from here and see what we get. So there's a couple of ways you can do it. You can either complete the square here on this expression. You can use quadratic formula, or you can use your calculator. You are allowed to use a graphical calculator to do this. So what we obtain is that t is going to be equal to, it's either minus 1.816 or it's going to be equal to minus 29.183. Now we need to work out the principal values, right? So I'm going to write this as p dot v. So the principal values we obtain by doing inverse tan on these numbers here. So if you do inverse tan minus 1.816, that gives me my first principal value. So my first one will be minus 1.067. And then my next one, if I do inverse tan on this again, minus 29.183, I'm going to get minus 1.536. So these are my two principal values. So we're nearly actually there now with this part C. In a way it's actually easier than part B. We're nearly there now, we just got to unwind it all. So therefore, the third time we're at will be 25. So R is 25. What you need to think about is using these two values, right? Which one do we pick? Well, what we're going to pick is we're going to pick the smaller one of the two. Because if I use this one, this is going to be the fourth one because it's a bigger number. So when I'm then undo it all, this will be the bigger value. So this will be the next, or there'll be the fourth value here, or the fourth time. So undoing all this, hopefully it's not too bad. So it's going to be two lots of minus this. So it's this value here we're using, remember, the smaller value, minus 1.536. Minus 1.536 plus 2 pi. And then whatever this gives us, this is that value. So this is equal to 9.494. So if we round it up to one decimal place, that'll give me 9.5. And there we go, that's part C. And finally for part D, this is a really long question. I've had to undo it all about 3 times. Part D, we're nearly there now, so we've just got to show that this model here for the foxes has been written like this. So they've done all the work for us with the substitutions. We've been given this model. And it says the number of foxes in the population is never 23,000 or more. We have to show that this is not true for the model that they've given. So what we're actually going to say here now is that this model that we've been given is equal to 23. So if I do it in black again, this means that this is equal to 23. That's what they're saying, right? Because again, it's in thousands already. So if I do this, let me just put this in white. What I'm going to do first, if this is equal to 23 and I've got a 5 plus the quotient of quadratics, I'm going to take the 5 off first. So this is this equal to 18. And then what I can do is times through by the denominator. Just like we did with this one here, when we did 0.8 times 25, it's going to be 1.3 times 18. So if you do all this, what you're going to get here is 23.4 t squared plus 54t, because it's 18 times 3, so 54t, or 3t should I say, 54t. And we'll have plus 75.6. And again, this is going to be equal to the numerator here of whatever we have left. So that's going to be equal to 13.7 t squared. Almost deciding not to work, t squared. And 22t. That's a plus, believe it or not. Plus 22t plus 66.3. Plus 66.3. So let's simplify this now. What we're going to get? So that's going to give me 23.4 minus 13.7. So it's going to give me 9.7 t squared. 9.7 t squared plus 32t plus 32t plus 9.3. And this is equal to 0, right? So this is the quadratic model we've ended up now when we've simplified. So what the case should be here is that there's no solution to this quadratic function that we've got here. If there's, if it's never 23,000 or more, what that means is that if you was to plot this as a quadratic, that it doesn't cross the x-axis. There is no real roots. So you can do two steps with this. You can either solve this using quadratic formula, completing the square, or using your calculator, or you can just work out the discriminant, right? The discriminant will show us whether there's real roots, 2 real roots, a repeated root, or no real roots. So let's do that. So it's going to be b squared, so 32 squared, minus 4 lots, so minus 4, times a 9.7 times c, which is 9.3. And what does that give us? Well, that is equal to 663.16, which is clearly bigger than 0, right? This means then that there is 2 real roots. So therefore, this model is not correct. The biologist model is not true. So therefore, I'm going to put a big cross to imply that it's wrong. And that's it. That's the full question done. So I know that was quite a long one, but hopefully it's okay once you broke it all down.